Okay, good morning. Last discussion natin is we determine the capacity of driven piles based on the formula or the theory. So if you recall, meron tayong dalawang assumptions that the pile is in under sand or the piles in clay. And also, uh, uh, we determined then na we have two resulting forces na included for the capacity. We have the end bearing piles or yung point, yung Q-tip, okay, and the skin friction, okay. Then for clay layer, meron tayong iba't ibang pag-solve for the skin friction. We have the alpha method, we have the beta method, and the gamma method. Okay, so right now, ang gagawin natin is we will discuss the elastic settlement of piles. Okay, so as you can see, pag nagde-design tayo ng structure, di ba? Ang kailangan nating i-serve is the strength followed by the serviceability. So kailangan nating mapapasa siya sa strength and serviceability. Okay? So paano natin ma-determine yung elastic settlement of piles? Okay? So kung ang driven piles natin, hindi natin ina-assume yung soil structure, yung soil interaction. Kung hindi natin ko consider yung soil interaction, so basically para din siyang para lang siyang column. Okay, if you know how to find the actual deformation of column, okay, or yung parang nagsosolve ka lang ng 2D frame, yan. Kung hindi mo siya i-consider yung soil interaction, you not consider the soil interaction, basically, the elastic settlement of piles is just like a superstructure like columns and beams. Yung analysis. However, merong complexity na madadagdag if we consider the soil interaction. Okay. So, the given formula for elastic settlement of piles is given by SE is given by the elastic settlement of pile plus the elastic settlement of pile caused by the load at the pile tip. Okay, and settlement of pile caused by the load transmitted along the pile shaft. Okay, so parang ganito yan. Yung una is yung elastic settlement of pile. Basically, para din tong consideration of the piles is still in elastic state. Okay, meaning linear yung material material deformation ito. Okay. Then for SE2, SE sub 2, settlement of pile caused by the load at the pile tip. So para din tong ano yung settlement that caused by the end bearing force. Okay. And SE3 is the settlement of pile, okay, caused by the load transmitted along the pile shaft. Okay. If the pile material is assumed to be elastic, the deformation of the pile can be evaluated in accordance with the fundamental principle of mechanics of materials. Okay. So if you recall yung formula nun, okay, naaalala niyo yung formula ng axial deformation. Okay. If you recall the formula of axial deformation, that is equivalent to PL over AE, right? That is PL over AE. Okay. Whereas yung stiffness natin is yung L over AE, yung axial stiffness. Ito yung tinatawag nating axial stiffness, L over AE. And ito yung ating axial force, yung P. Okay, is equals to the axial deformation, right? So basically the same lang siya. The same lang dito sa elastic settlement of pile or yung SE1. Okay? Kung mapapansin nyo class, this is yung P, this is the L, and this is yung AE. Okay? So ano yung force P? Okay? The force P is the sum of load carried by the pile point under the working load condition and the load carried by the skin friction or the skin resistance under the working load. So basically, ito yung total Q. Kasi 'di ba? Q sub P plus Q WS. Okay? Yan yung total Q. Okay? If you recall yung total Q natin, okay, yung total Q na kayang dalhin ng ating pile is equivalent to Q for the end bearing piles. Okay, iba lang yung notation dito class plus the skin friction. Ito yung sa skin friction. Yan. Ito yung total Q. Okay, so mapapansin nyo, meron siyang epsilon, magnitude epsilon. Okay, so before we discuss yung epsilon, the formula is Q sub P, WP is the load carried under the pile point, okay, working load condition. QWS is the load carried by the frictional resistance. A sub P is the area of the cross section of the pile. L is the length of pile, and E sub P is the modulus of elasticity of the pile material. Okay? Okay. Of the pile material. Okay? And the magnitude of epsilon will depend on the nature of the distribution of the unit friction resistance F along the pile shaft. Okay, so if the distribution of of F is uniform or parabolic as shown in this figure, your epsilon is equals to 0.5. However, the triangular distribution, okay, the magnitude of epsilon is equals to 0.67. So this comes from the theory of according to the study of Basic in 1977, study conducted by Basic in 1977. Okay, so ito yung assumption dun sa load distribution ng frictional resistance. So if we consider daw pala yon, okay, kung i-consider daw natin yung distribution of unit friction resistance along the pile shaft, hindi pala siya automatically 1.0. So katulad nung dati nating formula, yung una ko pinakita, yung epsilon nun is assumed to be uniform. Okay. But this time, meron tayong 3 cases. Itong distribution na to, yung letter A, this parabolic equation, okay, uniform. It is a uniform. Ito yung parabolic distribution. And ito yung isa na triangular distribution. Okay. So, ito yung formula for the first, yung elastic settlement of pile. Okay. So next, hanapin natin yung SE2, yung settlement of pile caused by the load at the pile tip. Okay. Oops, meron siyang okay. So yung SE2, SE sub 2. So the settlement of pile caused by the load carried at the pile point may be expressed in the form as one. Okay, Q sub WP is equals to SE2 is equals to Q sub WP times D all over ES, okay, multiplied by 1 minus mu squared S I sub WP. Okay, so discuss natin lahat. Yung D natin is the width or the diameter of the pile. Okay, take note yung SE2 is caused by the, okay, anong cause niyan? Yan yung dun sa end bearing force. Okay, yung end bearing force. Okay, so D is the width or diameter of the pile. Okay, what is Q sub WP? So napapansin nyo, maliit yung text. Okay, naka-small caps yung Q. Because ito yung point load per unit area of the pile point. So ang unit neto class is in pressure or stress. So para tong force over area. Yung force ng end bearing tip divided by the area. Okay, and E sub S is the modulus of elasticity of the soil at or below the pile point. Okay, so sa ilalim mismo ng pile point. Okay, kung napapansin nyo, ito yung piles, di ba? Yan. Then, meron yung contact area dito sa ilalim. Yan, ito yung, di ba, if you recall, this is your Q-tip. Okay, ito yung Q-tip natin. This is our Q-tip or tinatawag din nila na end-bearing force. Okay, so meron siyang contact area. Okay, that is your A sub P. And meron ding modulus of elasticity of the soil at that point. Okay, mu S is the Poisson's ratio of the soil. Okay, so if you don't know what is the Poisson's ratio, it is the ratio of the longitudinal and lateral strain. Okay, so yan yung based on the experiment, ito yung ratio of the longitudinal to the lateral strain. Okay, and next is the I sub WP. The I sub WP is the influence factor, and according to the equation, that is approximately equal to 0.85. Okay. The other formula for SE sub 2, or the settlement caused by the end-bearing force or the Q-tip, based on VESIC 1977. So he also proposed a semi-empirical method for obtaining the magnitude of the settlement of SE sub 2. Okay. His equation is given by this equation, Q sub WP is C sub P over D times Q sub P. Okay, so yung Q sub WP, okay, working force, okay, you know this one, that is the total force. C sub P is basically, yung D pala, yung D is the width or diameter of the pile. Yung C sub P is, ito lang yung bago, yung empirical coefficient. Okay? So empirical coefficient lang. So mapapansin nyo, yung Q sub WP divided by Q sub P, ano yung nakukuha natin dyan? That is the area. Okay, yan yung contact area. Okay, so bali pala, yung equation na to is basically area, contact area, times the empirical coefficient divided by the width or diameter of the pile. So ganun lang pala yun. So easy lang yung equation nito. Okay, so ito ay semi-empirical method. Okay. So, okay. Okay, sorry. Sorry. Yung Q sub P pala is the ultimate point. Alam ko may W. Okay, anyway. Sorry. Yung Q sub P is the ultimate point resistance of the pile. Okay. So, yung Q sub P is basically the same lang din siya dun sa equation natin. Q sub P is equals to the Q sub WP and yung ating ultimate resistance. Okay. Q sub WP divided by a factor of safety. Yan. Yan yung ating ultimate point resistance of the pile. Okay. Next is what are the value of C sub P? Okay, the value of C sub P or the empirical coefficient is given by table 11.12, this one. So for sand dense to loose, okay, dense to loose sand, your driven pile is 0.02 to 0.04. Okay, and for board pile, you have 0.09 to 0.18. Okay. Clay, stiff to soft, we have this equation, value, and this value. For silt, okay, we have this value and for this value. Okay, so this book comes from the Design of Pile Foundation by VESIC in the NCH-RP synthesis of highway practice. Okay. So ganyan yung pagsosolve natin for this SE sub 2 based on the VESIC equation. Okay, next natin is yung SE3. Okay, the settlement of pile caused by the load, okay, carried by the pile shaft, that is given by a relation similar to this equation, 11.64. Okay, similar to this one. Okay, so this time naman, yung SE3 is given by Q times Q sub WS over P times L multiplied by D over ES, okay, multiplied by 1 minus mu squared S IWS. Okay. So yung Q sub WS is okay, the force yung due to friction, Okay. Yung parang yung Q sub F natin na notation. So open ko lang yung discussion natin last meeting. Okay. So yung notation nito this time ang notation nito is yung Q sub F. Okay, yung Q sub F. Okay, yung QWS is yung Q sub F divided by your P times L multiplied by D over E. Okay? Yung D natin is diameter pa rin ng piles or the width of the pile. E sub S is yung modulus of elasticity of the soil. Okay? 1 minus mu squared S. Okay? And IWS. IWS is the influence factor. Okay? The question is, same pa rin ba ng IWS, the influence factor? Okay. Yung influence factor this time, okay, in this equation 11.66, okay, is given by this equation. 2 plus 0.35 square root of L over D. Okay. Whereas your L is the length of the embedded length of the pile. Okay. So, take note that yung equation 11.66, itong equation na to, yung QWS over PL is the average value of F along the pile shaft. Okay? So, average value of F along the pile shaft. Okay, bakit? Because P times L is basically the surface area. Okay, di ba? Yan yung surface area. Okay. And your QWS is yung total force acting on the surface area. Okay, the surface area sa labas. Okay, so therefore if you divide it, that is the average value of F along the pile shaft. Okay, so yung parang force per unit area. Okay, siya yung force per unit area. Okay. And ito na yung bago nyong IWS. Okay. And if you check the same equation given by Vesic, yung simple empirical relationship, the equation, this one, yung SE3, can be modified to medyo malabo. That is QWS C times CS over L sub QP. Okay. So, yung C sub S is the empirical constant given by this equation. And yung CP is the same and given by 11.12. Okay. So, meron tayong ginagamit na pre-stressed concrete. So, pwede tayong gumamit ng pre-stressed concrete in piles. Okay. So, we have here yung typical pre-stressed concrete pile in use or in SI unit. Okay, so ito yung mga properties nung typical concrete pile. Okay. So, if your pile shaft, okay, yung S and O, S is for square section and O is for rectangular section. So, most of the time kasi makikita mo na pile section is either a square or the octagonal shape. Okay. So given din yung mga diameter. So we have 254, 305, 356, 406, 457, 508, 559, 610. Okay. Yan yung mga typical diameter. Okay. So 254, that is 10 inches. 305, that is 12 inches. 10, 12. Okay. So every 2 yan, every 2. Okay. So the area of the cross section. So para hindi na kayo mag-solve ng area, so basically nandito na, written na yung area. And written na rin yung perimeter. Okay. Then the number of strands. Okay. So kunwari, the square section with diameter of 25 with the width of 254 with a 12.7 millimeter diameter. Okay, 4 na piraso. Okay, yung minimum effective pre-stress force is 312. We have the section modulus and that the capacity of the pile. Okay, if your concrete compressive strength is 34.5, therefore that is 556 kilonewtons. Kapag 41.4 megapascal yung compressive strength ng concrete, okay, we have 778 kilonewtons. So ganito lang yung paggamit nito. Okay. Also have this one in English unit. So mapapansin nyo every 2. So we have 10, 12, 14, 16, 18, 20, 22, and 24 inches. Okay, diameters. Okay, the perimeters and the cross section, number of strands. Okay, 1/2 inch diameter. 1/2 inch diameter is 12.7 millimeter diameter in SI. And 7/16 is 11.1 millimeter diameter. Okay. Then we have this other properties. Okay. So ganyan lang yung pag-solve for the elastic settlement. Okay. So ito, mga values na to, magagamit natin to for the design bearing capacity. So na rin hindi pa given yung design bearing capacity. So we can assume yung bearing capacity. Okay. So the common cast in place concrete piles, ito yung makikita nyo sa mga site. Okay. Ito yung Raymond step taper pile. Okay. It is a corrugated thin cylindrical casing with maximum usual length of 30 meters. Okay. The monotube or union metal pile. Okay. The western casted pile. Okay. The seamless pile. Okay. The Frankie case pedestal pile. Okay. Meron siyang tip dun sa dulo. Okay. And we have the western and case pile without the pedestal. Okay. Ito yung may pedestal. Hindi ito tawag nila ng pedestal. And the Frankie and case pedestal pile. Okay. So let's have an example problem to determine the determining the elastic settlement, the total elastic settlement. Okay, so this comes from the book of Principle of Foundation Engineering by Brahadas. Okay, the allowable working load on a pre-stressed concrete pile that is 21 meters long is driven into the sand, which is equals to 502 kilonewton. Okay, ito yung allowable working load. Okay, so basically ito siya. Ito yung Q sub T. Okay, ito yung Q sub T. Okay, so next natin is, according to the problem, the pile is octagonal in shape with D is equals to 356 millimeters. Okay. So the skin resistance carries a 350 kilonewton of the allowable load. Okay. It was assumed that the total skin resistance is 350 kilonewtons. And the point bearing carries the rest. Okay. Using E sub P or the modulus of elasticity of pile to be 21 times 10 raised to 6 kilonewton per square meter. The modulus of elasticity of the soil at below is 25 times 10 raised to 3 kilonewton per square meter. The Poisson's ratio, that is 0.35, and the epsilon value is triangular loads. Okay, assumed to be triangular load. Therefore, that is 0.62. Okay, determine the settlement of the pile. Okay, so before we start, may mga ang kailangan natin gawin, type muna natin lahat ng given din. So pwede natin gawin to. So para maging systematize yung pag-solve, pwede mong gawin, right? Take down all the given before you start. Okay, doon ka magkakaroon ng idea na paano ba yung approach? Okay, paano ba yung ano ba yung unknown pa? So pwede 'yon, mga ganong way. Okay. So we have a diameter of the pile which is 356. The length of the pile, that is 21. The total load, allowable working load, is 502. Okay, your QWS is 350 kilonewton. Okay, your E sub P is 21 times 10 raised to 6. E sub S is 25 times 10 raised to 3. Poisson's ratio 0.35, epsilon 0.62. Okay, so let us go back to the total equation, yung working equation natin. Okay, di ba yung total settlement is basically SE1 plus SE2 plus SE3. Okay, so kailangan natin hanapin isa-isa yung SE1, SE2, SE3. Okay, for the SE1, we have this formula, yung parang PL over AE. Okay. So, ito, that is your Q sub WP and your QWS. Okay. Since yung allowable working load mo is 502 kilonewton, and according to the problem, 350 kilonewton daw nun comes from the skin friction. Okay. So, the rest, which is equivalent to 152, is your the end bearing force. Okay, yung Q-tip. Okay, so that is 152 kilonewton. So if we use the formula, therefore that is 152 plus 0.62. Okay, yan yung F mo, yung F due to the linearly increasing skin friction times 350 for the skin friction, and total length is 21. And yung E sub P mo is 21 times 10 raised to 6. So saan yung A sub P mo? Yung area of your pile. Okay. So go back doon sa table. So sabi niya dito 356 octagonal shape. So which is equivalent to 356 octagonal shape, that is 1045 cm squared. Okay. So 1045 cm squared. So convert it to square meters. That is 0.1045 square meters. Okay. And therefore, pretty straightforward answer. So this is in kilonewton, this is in kilonewton. Your E sub P is in kilonewton square meter. So all units is in meters. So ang final answer nyo is in meters. So multiply it by 1,000, you have 3.35. Should be 3.53 meters. Okay? So 3.53 millimeters pala. Sorry, 3.53 millimeters. Okay, so do you have questions for SE1? Okay, may question ba kayo? Okay, clear naman guys yung first settlement natin. Okay, next is yung SE sub 2. Okay, yung SE sub 2. So SE sub 2 is given by this equation, Q sub WP times D over ES 1 minus mu squared S I sub WP. Okay. Whereas your I sub WP is assumed to be 0.85, the influence factor. Okay. So before we start, take note of this one. The Q sub WP is the force. Okay, naka small letter yung Q. So therefore, that is the force per unit area. Okay, therefore that is Q sub WP divided by A sub P, or ito yung pressure dun sa Q-tip. Okay, ito yung pressure dun sa Q-tip. Okay, so therefore, your Q sub WP is 152 divided by 1.045. Ito yung Q sub WP mo. This is your Q WP. Ayan. Next, your D over ES. Ito yung D mo, which is 0.356 meters. Your ES, modulus of elasticity of the soil, is 25 times 10 raised to 3. And your 1 minus mu S is, your mu S is 0.35 and the influence factor is 0.85. So pretty straightforward answer. Again, the SE sub 2 is equivalent to 15.5 millimeters. Okay? So walang problema dito sa problem. So madali lang rin siya i-solve. So kailangan niyo lang talaga yung mga understand yung yung mga values. Okay, next. Again, from equation 11.66, hanapin naman natin yung SE3. Okay. So ang gagamitin natin, hindi natin ginagamit yung vesica. So baka ginagamit yung vesic na empirical equations. Okay. So ito yung ginagamit natin yung general muna. Okay. Okay, so if you go back to the equation SE3, that is Q sub WS over PL, okay, D over ES, 1 minus mu S squared, IWS. Okay, so if you can see, para rin siyang the same dun sa equation na to. The same siya sa equation na to. Ang nagbago lang is yung Q sub WP. Okay. Yung Q sub WP, pinalitan ng Q sub WS. Okay. This is the force per unit area due to the skin friction, yung skin friction. Since naman yung skin friction kasi acting on the total surface area, the skin friction acting on the total surface area, syempre siya yung may contact doon sa soil sa labas. So therefore, if your total load due to the skin friction divided by the surface area, so meron ka ng force per unit area. Ito yun, which is this one. And d over es still the same, 1 minus mu squared s, 1 minus mu squared s, or mu squared is the same, and IWS is the same. Okay, however, IWS is different. Okay, this one is IWP, or the influence factor due to pile. Ito, the influence factor for the skin friction. Okay. So QWS over PL, okay, that is 350 divided by, ano yung perimeter? Okay, yung perimeter, go back again dun sa table, that is 356, di ba? 356, hanapin mo yung cross, yung perimeter octagonal shape, that is 1168 millimeters. Okay, so 1168, so 1.168 meters yon, times mo sa 21, that is, ito yung Q sub WS mo, yung small letter Q, WS. Okay. Next, yung D over ES is 0.356 over 25 times 10 raised to 3. 1 minus mu S squared, that is 1 minus 0.35 squared. Okay, then what is your IWS? The influence factor in the skin friction, okay, for the skin friction. It's given by 2 plus 0.35 square root of L over D. Okay. So your L is 21, your D is 0.356, therefore your IWS is 4.69. Okay. So plug in mo tong value na to dito sa equation SE3, you have 0.0084 meters. Okay. And 0.0084 meters is approximately equal to 0.84 meters. Hence, the total settlement is the sum, okay, the sum of SE1 plus SE2 plus SE3. Okay. Therefore, that is 3.35 plus 15.5 plus 0.84. Therefore, the total settlement, okay, in the pile is 19.69 millimeters. Okay. So, do you have any question for elastic settlement of piles? Any clarifications? Okay. Okay. So, before I end this discussion, so let us summarize na lang yung nangyari in this module, okay, para mas madali niyong maintindihan. Okay, so for module 20, elastic settlement of piles, okay. Basically it is the sum of three factors. Yung elastic settlement of pile, okay, assumption that is still elastic condition, so PL over AE, okay. Whereas your P is the total working load equation Q, okay. And plus the, okay, the epsilon Q sub WS, okay, the working pile equation for the Q-tip plus the influence of the load distribution factor due to F, or due to the skin friction. Okay, and SE2 is given by this equation, whereas your small letter Q sub WP is the load per unit area at the pile point, or basically your Q-tip divided by the area at the tip. Okay, so that is force per unit area at the Q-tip, or the pressure at the Q-tip, the tip of the pile. Okay, given by this equation, d over es, 1 minus mu squared s, IWP, and the influence factor for the end-bearing piles or end-bearing, sorry, the Q-tip, sorry, for the bearing is 0.85. Okay. And as you can see, meron tayong basic equation or simple empirical method. Okay. And next is for the SE3, that is due to the skin friction. So it is the same and similar to the relation given by this equation. Okay, ang nagbago lang dito is yung Q sub WP. Your Q sub WP is uh, force per unit area at the tip. Pero dito naman, Q sub WS is the force per unit area along of force per surface area. Force per surface area or force per unit surface area. Okay, so basically the total frictional force divided by the surface area is your this one, and the same, which is d over es, 1 minus mu squared s, and the influence factor this time is given by this equation. Influence factor due to the skin friction is given by this equation. 2 plus 0.35 square root of L over T. Okay, so, and also we have the basic equation for the empirical relationship. And you can check itong naka-table for you to not to solve the area and the perimeter. And also meron tayong design bearing capacity given by this table. And we have this table. Okay, so that's it for this topic. And if you don't have any questions, okay, so maybe we can leave early, okay, for this meeting. Okay, so again, thank you class for listening.
Thank you, sir.